It is now time to learn how to solve problems that involve Newton's second law in terms of momentum. Question 1 reads as follows. A 700-gram tennis ball moves horizontally straight towards a wall at 9 meters per second. The ball collides with the wall and it is in contact with the wall for 0.005 seconds before it rebounds with a velocity of 12 meters per second. Now we are on question 1. And we are saying here that we have a wall like this, and there is a ball that moves towards this wall with an initial velocity of 9 meters per second. Now I'm going to choose my direction using the reference frame of reference to say anything that goes to the right is positive and anything that goes upwards is positive. So this is to say my velocity is positive because it goes to the right. And this ball here, they say it has a mass of 700 grams, sorry. So this means here we have a mass of the ball to be 700 grams. Remember that we said the SI unit for mass is kilogram. This means we have to convert this gram into a kilogram. Now, probably you know how to do this because they taught you this in grade 10 and also 11. But just to do a revision, or if you forgot, I'm going to just show you quickly here. We have a conversion factor that says 1 kilogram is the same as 8,000 grams. The best way to do this, or a trick that you should use to convert this 700 gram to a kilogram, is that you can write the 700 gram the way it is and you multiply by. Now I'm going to take this 1,000 and put it as a denominator. I'm going to put the 1,000 as a denominator because I want the gram and the gram to cancel. So that means I then take the 1 kg and put it as a numerator, so that when these two they cancel, I'm only left with a kilogram, and that's what I want. So when you do this on your calculator, you would be able to see that this should be 0.7 kilogram. The gram and a gram will fall out. And basically here the 0 and the 0 would cancel here, and I'm left only with 7 divided by 10, and that's like a 0.7. Or you can use a calculator after you have written this problem with a conversion factor. If you use this method, conversion of SI units become easy. Now, some of the keywords to look at is that the ball moves horizontally straight, right? That's very important to notice because the ball is moving straight towards the wall. Now, the question continues here to say, okay, the ball will collide with the wall. So this means here that as the ball comes towards the wall, eventually it will collide with the wall, right? And they say that it is in contact with the wall for a very small time, like 0.005 seconds, before it rebounds. So what is actually happening here is that the ball will be in contact, it will collide with the wall and will be in contact for a time period of 0.05 seconds. During that time, the wall is actually exerting a force on the ball, F net, is actually applying the force on the ball. When it collides with it, it pushes the ball backwards. This is the reason why the ball actually will rebound. It will then rebound, it will go back and rebound and reach that velocity of 12 meters per second. So here, we'll have the ball moving backwards with a velocity of 12 meters per second. Now this velocity would be negative because it is going in the opposite direction of what we chose. It's going in that direction. This is the negative direction. This is the negative direction. It's going opposite to what we chose to be positive. And because this is a change in velocity, remember, we started with this velocity. Now we have this velocity after collision. It means it will be the final velocity. So here it will be before we collide with the wall. This would be during the collision with the wall. And this is after the collision with the wall. Now, all that I've done here, we call problem interpretation. That means I've interpreted my problem. I'll call that I for problem interpretation. The other thing that I'm going to do when I look at this problem would be to observe or ask myself, which part of physics does this problem deal with? What type of equations am I going to use when I solve this problem? Well, I can see that this is the part that requires me to understand the change in momentum because I have the mass here, so I have initial momentum here. Then after the collision here, I have again final momentum. So the momentum has changed from initial to final because my velocities are changing from VI to VF. And there is a force involved here. The wall exerts a force on the object over a certain time of period. This then tells me that I can use Newton's second law. I'm thinking in my mind that I see this relationship, Newton's second law, in terms of momentum. Maybe I could be asked to state Newton's second law in this problem, or to calculate change in momentum, to calculate the net force. Those are things that I'm anticipating to get from my questions. When you do that, we call that problem classification. We have classified our problem to say which part of physics does it fall under. Now I'm going to answer my questions. When I do that, I'll call that A to say I'm answering the questions. Question 1.1 says, state Newton's second law of motion in words. To answer this problem, I'm going to then say the net force acting on an object is the same as the rate of change of momentum. This is the law, or rather the equation that Newton originally wrote when he was studying these things. We talked about it in the previous lesson. You can also state this law differently using acceleration, without using momentum. That also will be fine. How we used to state it in grade 11. I'm using this specific way of stating this law because I can see that it involves momentum here. This question is worth 2 marks, so they're going to give me 2 marks for writing that statement. But to get the full 2 marks, it is important to also do what we call N here, problem navigation. Problem navigation involves you looking at your answer after writing it down to see that it doesn't have mistakes and you wrote everything properly. So you literally go through what you wrote and check if there's any mistakes. And all that should be it should take you no longer than 2 minutes because it's 2 marks. So here I can see that my statement is really written well. There's no errors here, grammatic errors and everything. I will then go back and answer the next question. 1.2, it says here, calculate the net force exerted by the wall on the ball. So when we did our problem interpretation, we noticed that the wall will actually apply a force on the ball. That's why the ball is going backwards, because it when they collide, it pushes the ball backwards so that it goes back in that direction. So we want to calculate this force now. This is 1.2. Now, in my problem classification already, I did mention that I could be asked to calculate the force because we identified the relationship of Newton's second law, that the net force is equal to the change in momentum. Now, at this stage, I'm going to write this as m times v minus v initial. Remember that this is the change in momentum, is another way of writing change in momentum. Then I'm going to divide by the change in t. And I'm going to substitute at this stage to say my mass is 0.7. My final velocity is 12 meters per second because it goes to the negative direction. And then we have minus 9 here. Remember, there's a minus here. And we're dividing this by the 0.005 seconds that the ball is in contact with the wall. At this stage, this question becomes very, 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 very boring because you just use your calculator to get the final answer. Now I'm going to pull my calculator to punch all this in a calculator so that I have the 0.7 multiplied by negative 12 minus negative 9, and here I have a 0.005. And this gives me an answer of negative 2,940 newtons. So at the end of the day, this tells me that my net force is equal to 2,940 newtons to the left, because remember, negative would mean that we are going to the opposite direction, to the left, the opposite of positive, to the left. Now remember, we are at the point where we are answering our question. Now we have the answer. We need to navigate the answer. We need to see if this answer makes sense and there's no errors. I wrote the correct symbol here. I wrote the number and the SI unit. I've also given direction because I acknowledge that net force is a vector quantity. So everything seems okay to me. Maybe I may want to interpret this answer, the negative, the direction, to say here is negative and negative means left. Does that make sense? When we look at how we interpreted this problem and this situation, it does make sense because we expect our net force to go to the negative direction. And that's how I gain confidence about my final answer, by actually navigating the answer to see if it makes sense. Now we are going to continue with the questions, meaning we go back, we cycle back to answer, we answer the question. because we have another question to answer. 1.3 reads as follows. What is the net force exerted by the ball on the wall? Remember that we have the force that the wall exerts on the ball. This is the force of the wall on the ball. It pushes the ball back so that it goes in that direction. The question is asking us to calculate the force that the ball will exert on the wall. Obviously, when the ball comes from this direction, when it hits the wall, it will push the wall with a force that is going in that direction. So there will be a force of the ball going in that direction, experienced by the wall. And maybe this force, I can call it F of the ball on the wall. FBW, I can call it that way. Now, what is going to be interesting here is that how can we then calculate that force or find that force? And in fact here, the question gives us clues to say we shouldn't calculate, because they say what, we should just write that force. And it's actually also 1 mark. Right, it's also 1 mark. Now, this question, when you look at it properly, you would see that when the two collide, when they're in contact with each other, they will exert forces on each other that are equal, but they point in opposite directions. We know this from Newton's third law of motion to say when two objects exert forces on each other, they will exert forces that are equal in magnitude but opposite in direction. In other words, the force that the ball exerts on the wall would go in the positive direction, and the force that the wall exerts on the ball will go in the negative direction. So this means this force here is negative, and in fact we calculated this force to be negative. Now at this stage we can answer that question to say the force of the ball on the wall, FBW, will be equals to 2,940 Newton to the right. It must go to the right. It's the same magnitude that we have, the same force in magnitude that the wall exerts on the ball, but now it's going the opposite direction. The previous question was worth 3 marks because we did the full calculation. We are going to get marked for writing the formula, which is in the formula sheet again. That's a free mark. Then we're going to get the mark for correct substitution of everything here. Then we're going to get the mark for the final answer. With question 1.3, they only give you 1 mark because you don't do any calculations. You can do this question by calculation, but you have to be careful. You'll waste time. 1 mark would mean 1 minute. You should really be able to see this without a calculation. And because this answer didn't involve any calculations and anything in terms of navigation, in terms of us doing navigation, because we are done answering the question, we can just check if we wrote everything properly. Did we copy this correctly? Did we write this correctly? We changed this from left to right, and be sure that your answer is written correctly. Now we're going back to the A for answering the question, right? We're going back to the A for answering the last question. The last question says, name the law required to answer question 1.3. So what law did we use to answer question 1.3? What law did we use to answer this question? This should be an obvious and straightforward question because we talked about it when we were trying to find this law here. When we were answering that question, we said that we are using Newton's third law of motion. And this is only 1 mark. You can even do it within a minute, less than a minute.